In this video, we're going to see how to import local datasets into Trends.Earth. So I'm going to click in the Datasets tab, and then down below, we're going to see Import Datasets. So here we have several options. So we have load existing Trends.Earth output files. So if you have a file that someone has shared with you or that you have on your local machine and you want to import it, we have import custom productivity, import custom land cover, soil organic carbon, and also population data set. So for this exercise, I'm going to show you how to import a local custom land cover data set. So I'm going to click here, and then we see this dialog popping up. So for this one, I'm doing an exercise for the Bahamas, which I have some local data sets representing land cover classes. So here we can see that I'm navigating to a folder in my computer, and I have a land cover for the year of 2000, and I have a land cover for the year of 2023. So I select that file, so raster. But if by any chance you have a polygon data set representing land cover classes, you also have the option to import shapefile, KML, KMZ, or a GeoJSON. But in my case, I have a raster file. It has just one band, so the band is just one band, so that's the band that is representing the land cover classes. And then we know that this one is for the year of 2000, and the node data value is standardized here. So, and I'm not going to modify the resolution. So I know that this data set was derived from Landsat data. So that means that it has a spatial resolution of 30 meter per pixel. And then obviously I need to tell Trends.Earth the equivalence between the original the original land cover codes and the ones that UNCCD recommends. So I've done this exercise previously. So I know that 0 corresponds to water body, 1 represents grassland, and so forth. So I can save this definition to file, as I've done previously. So I will just do land cover classes for the Bahamas. And then I can later on load this instead of having to go through each code, each ID there. So, okay. And now I can also insert the data, the metadata. So land cover for Bahamas 2000. And then I go on and fill the author, and you can see that once we fill here any information, so let's just put my name, it goes from red to green, but that's just an example. It was not me who have produced this data set, so it was shared with me. And then I hit OK. So then we're going to see here that Trends.Earth is going to start importing this data set. So it's importing the raster, and then it's going to reclass. Then for land cover zoom indicator, we need at least 2 data points, right? So we need a land cover layer representing the initial year, and we also need a land cover layer representing a final year, so we can assess changes in land cover classes, right? So I'm gonna repeat the same step here. So I'm gonna go to import dataset, import custom land cover dataset, and now I check that it's still the region of interest is still the Bahamas. Again, I have another raster dataset, not a polygon, but if you have a polygon, a vector, you can import a vector dataset. So, and then I'm gonna navigate to the folder in my machine where I have the land cover layer for the Bahamas for the year of 2023. So now I mapped it through the browse option here. I know now that this layer is for 2023, and similarly, I need to go through matching the land cover classes, the original ID with the land cover classes. So here, just for an example, I can just like import that JSON file that I just saved. I saved in the previous example. So I open, then we see that we have the match between the original ID and the land cover classes that UNCCD recommend. I can hit OK now, and then once again we're going to see trends.rf status bar showing to us how that this process is running in our machine. But I have done that previously, so now it's importing. The Bahama is not too big, but we can see here that I've imported these in a previous step as well. So I already have these layers imported into TrendsEarth. So now I'm going to go back to the Algorithms tab, go to the land cover change Zoom indicator option, and now what I'm going to do is, instead of executing remotely, I'm going to execute it locally. So I click on execute locally, and then the dialog pops up. So, and here for the initial year, I'm going to set the data set that I imported for the year of 2000. And for target year, it's the Bahamas, land cover 2023. So now I'm going to name this job, this task, land cover change 2000 to 2023. And here you have to carefully set the transition matrix for land covers from the initial year to the target year. So if a pixel used to be grassland and changed to cropland, you can change this to negative, stable, or positive. So please make sure to customize these cells, the transition matrix, according to local knowledge and scientific arguments instead. But yeah, make sure to do these very carefully. And then once this exercise, this dialog is set, you can execute locally. But I've done that already. Instead of waiting for the process to stop, to finish, I'm just going to go back to the data sets, and I'm going to show you that I've done that. I've done the land cover change from using the local custom data sets. So I'm going to add those to the canvas. So we can explore it a little bit. But most importantly, now that I have the land cover change assessment, what I'm going to do, so we can see here the differences for the Bahamas. Now, what I'm going to do is to run the SDG indicator 15.3.1 using the custom land cover layers that I just imported. So here I've ran previously for the exercise the trend degradation, land productivity assessment also from 2000 to 2023. So I'm selecting the trend degradation from 2001 to 2023, the performance land productivity metric for 2001 to 2023, the state metric also for the same time series. Here is where under land cover, this is where I'm going to select the land cover degradation layer that I assessed for the Bahamas from 2000 to 2023. And here I've also prepared the soil organic carbon for the same time series. So for this time, I'm not going to use the population because I'm using a slight different time series here. But then I can integrate all the sub-indicators into the Bahamas 15.3.1 using custom land cover layer. So I hit execute locally. So once again, I've done this previously, so I'm not going to run it again here, otherwise it's going to get busy. But I can show you, because I've done that previously, I can show you that I have here the Bahamas SDG 15.3.1 for this year from 2001 to 2023. So I can add those layers here to the canvas, and then we're going to see that we, instead of using the global land cover layers that is produced by the European Space Agency, instead of that, I used a local data representing land cover classes for doing the assessment of SDG 15.3.1 for the Bahamas, spanning 2001 to 2023. This is a hypothetical exercise, but we can see here that now we have the SDG 15.3.1 for the Bahamas.